R6 introduces complex numbers. We usually work with the real numbers. Complex numbers are a set of numbers that deal with the number I. The number I represents the square root of -1. That's what's equal to I. So this allows us to actually take the square root of a negative. So you probably heard many times that you can't take the square root of a negative. It's not entirely true, only partially true. You can't take the square root of a negative and get a real number. However, you can take the square root of a negative and get an imaginary number. That imaginary number deals with the number I. Those are called complex solutions. So we know I is equal to the square root of -1. So I squared is equal to -1. We find that by squaring both sides. Square root of something squared is just that something. And then we're left with I squared. So I squared equals -1. So then if we're trying to simplify a radical that's negative, then we can take out an I and make it positive. Because that would be like saying, okay, square root of -1 times square root of b. Because we're saying here I square root of b. So square root of -1 times square root of b, and you can multiply what's inside of radicals, gives you negative square root of b, or square root of -b. So now we can use that property to rewrite these expressions. So for the square root of 81, we can take out an I for the negative, and then we're left with just square root of 81. We can take the square root of 81. Square root of 81 is 9. So then we get 9I. Square root of -50. Again, we need to take out an I because we have a negative under the radical. And then we're left with square root of 50. We can see if we can simplify square root of 50. 50 is equal to 2 times 25. 25 is equal to 5 times 5. So we do have a pair of 5s and a 2 left over. So square root of 50 can be rewritten as 5 square root of 2. But now we had already taken out an I. We've now taken out a 5. We have to take out both. We can't get rid of that negative, or that I, because then we wouldn't end up with the negative if we went backwards with it. And then we had square root of 2 over here. So 5I square root of 2 would be the same thing as square root of -50. Then we have square root of -11. We need to take out an I for the negative, and then we're left with positive 11. And we can see if we can reduce square root of 11, but we can't because 11 is prime. The only factors of 11 are 1 and 11. So then this is it. Square root of -11 is equal to I times square root of 11. Now we can also simplify expressions involving I. What we want to do is treat I as if it's a variable. Even though it's really not a variable, it represents a specific number. But because it's a square root involved there, you can only combine like roots. So we want to treat I as if it is a variable because we can only combine things with I because it's representing a square root. So we can combine 2I and -3I. And we also have like terms of 4 and 2. So 2I minus 3I is -I. And then 4 plus 2 is 6. So this expression can be written as -I plus 6 or 6 minus I. We typically see it with the constant in the front. So 6 minus I would be our simplified version of that expression. We can also multiply it, and again, we just want to treat I as if it's a variable. So here we have a binomial times a binomial. So we can FOIL. 10 times 10 is 100, minus 10 times 3I, or plus 10 times 3I is 30I, and then minus 3I times 10 is minus 30I, and then -3I plus 3I is -9I squared. So what's going to happen here is 30I and -30I are going to cancel. And then we're left with 100 minus 9i squared. But we're not finished. If you recall, we said I squared is equal to -1. Anytime we see I squared, we want to replace it with -1 because that means we've actually come up with a real number if we get rid of everything with I. So we're going to replace this I squared here with -1. So now we have 100 minus 9 times -1, which is equal to 100 plus 9, and we get 109. So multiplying these two binomials involving I, these two complex binomials, actually resulted in a real number, 109. So notice that we completely eliminated I in that example. We don't want I in the denominator of a problem because I is a square root and we don't like to have square roots in the denominator. So when you rationalize the denominator with a square root expression, you can also rationalize the denominator in an expression that involves I. To rationalize or divide complex expressions, we want to multiply by the conjugate. If you are familiar with the conjugate of, say, a plus square root of b, it was a minus square root of b is the conjugate, and that would eliminate your square roots if you multiplied by the conjugate. The same thing works with I because I is a square root. So if a plus bi is in the denominator, we can multiply by a minus bi. And if a minus bi is in the denominator, we can multiply by a plus bi. So here we have an I in the denominator. We have 2 minus 7i. That represents a square root, so we want to get rid of it. We can get rid of it by multiplying by the conjugate. Well, we have 2 minus 7i. Its conjugate would be 2 plus 7i. But we're only allowed to multiply by 1. That's the identity. So we also have to multiply by 2 plus 7i in the numerator. So now, we multiply our numerators, multiply our denominators, and we can FOIL. And again, you can use the box method if you prefer. So now 5 times 2 is 10, and then 5 times 7i is 35i, and then 6i times 2 is 12i, and then 6 times 7 is 42. I times I is I squared. So that's our numerator. Now we can multiply the denominator. 2 times 2 is 4. 2 times 7i is 14i. Negative 7i times 2 is negative 14i. And then negative 7i times 7i is 49i squared, or minus 49i squared. So now from this point, in our numerator, we can combine these like terms, 35i and 12i, and I squared is equal to negative 1. In the denominator, we can cancel 14i and negative 14i, and I squared is equal to negative 1. Notice that we won't have any i's left in the denominator, which is exactly what we want. So now we have 10 plus 47i, 35i plus 12i would be 47i, and then plus 42 times negative 1. In the denominator, we'll have 4 minus 49 times I squared was negative 1. So now in the numerator, we have 10 plus 47i minus 42 over 4. Negative 49 times negative 1 is positive 49. So now we have 10 minus 42, which would be negative 32. We have like terms here. So negative 32 plus 47i, and that's over 49 plus 4, which is 53. So now we have divided.